Okay, 8C, we're going to look at something called the fundamental theorem of algebra, and it sounds really super important and probably hard to do, but it's actually not. It's really easy. So, first thing is we want to talk about the word multiplicity. So the multiplicity is the number of times that a factor appears. So sometimes we can factor something, and let's say I factored something and I got these as my factors. So I got x plus 2, x plus 2, x minus 3. Or sometimes you might see it written as x plus 2 squared, x minus 3. So if I had an equation that I factored, and I have something that appears more than once, that has a multiplicity of 2. And what that means on a graph is at -2, because I would set this equal to 0 and solve. So at -2, the graph is going to touch the x-axis and turn around. So it would look something like this, like where my graph, I would have zeros at -2, and this would have a 0 at +3. Okay, and at -2, the graph would touch it and then turn around. And then somewhere over here, it would come back and then touch that 0. Okay, so this is what it looks like when something has a multiplicity of 2. It just means that the factor shows up twice. Okay, so what we're going to do is we're going to find the zeros by graphing, and we're going to use the zeros to sketch the graph. So you're going to put this in your calculator and graph it. Okay, so I have it graphed here. If yours looks a little different, remember you can always go back to the standard viewing window. So you press F3 and then press F3 again. If these numbers are crazy, it'll change it back to -10 to +10. And then you can go back and see the graph. So if I look at this graph, I count 1, 2, 3 zeros, 3 places where it crosses the x-axis. Okay, and this one right here, whatever this is, has a multiplicity of 2 because it hits that line and then it hits the x-axis and then turns around. So we're going to find the zeros the same way you did with quadratics. We're going to do g-solve and root, and I'm going to write them down. So I have a 0 at x equals -2. Okay, so x equals -2. Then I use my arrow to go over. I have a 0 at x equals 0. And this one has a multiplicity of 2 because that's where the graph hits the x-axis and then turns around. And then I have one more 0 over here, and let's see what it is. X equals 4. Okay, so now I can kind of sketch this graph. I know I have a 0 at -2. I have a 0 at 0, and I have a 0 at 4. All right, and if we kind of look at this, this side is increasing, so it's going to go like this. Going to hit that 0 and turn around. And then way down here somewhere, turns around again and goes back up through there. And so that's kind of a sketch of that graph. And we can talk about some other points that you could find, but for now, as long as it goes through that zeros, that's pretty good. All right, so the fundamental theorem of algebra, big fancy title. Okay, if it has a degree where n is greater than or equal to 1, then blah, 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 blah. Lots of fancy math words. Basically what this says is, as long as your polynomial is not just a constant, not just a number, if it has an x anywhere in there, all right, then the number of roots, okay, is equal to the degree. All right, the number of roots, whoops, got an extra e in there. The number of roots is equal to the degree. And remember, the degree we talked about the first day of the unit is the highest exponent. Okay, so whatever the highest exponent is, that's how many roots that polynomial has. Now, some of them will be real roots, which are the ones that we can see when we graph them, where it actually touches the x-axis. And some of them will be imaginary roots. Remember, like we did back in Unit 5, where the number under the square root was negative. So we simplified the I out, and we had like those imaginary answers. All right, so total number of roots is equal to the degree. So highest exponent is 3, so there are 3 roots here. And then what we're going to do is look at the graph. So I'm going to get my calculator back out, and I'm going to graph this, and I want you to do the same thing. Okay, so there's our picture, and I look and I only see one place where this graph touches the x-axis. So that means it has one real root and two imaginary roots, because these numbers have to add up to this, okay? The thing about imaginary roots is they always come in pairs. So your number of imaginary roots right here always has to be an even number. 2, 4, 6, 10,000, doesn't really matter. It just has to be an even number because they always come in pairs. Alright, so I want you to try this one right here. So graph it, alright, and then see if you can figure out all of these answers.